In the last part of this chapter, we are going to see two old friends. One is called HCF, highest common factor, and the other one is called least common multiple, LCM. Besides you see highest common factor, sometimes we'll see a term which is called GCD. This is called greatest. Okay, let's wait. Greatest common divisor. So when you see this word, it also means that you are going to find the HCF. So let's recall some ideas or memory when you had in primary school. So first of all, you are going to list out all the factors of 12 and 30 respectively. So that's why we have 1 times 12. I like to put in the front at the end. 2 times 6. And finally 3 times 4. Totally 6 factors. While 30, you have 1 and 30. 2 and 15. Anything else? 3 times 10. And also 5 times 6. Totally 8 factors. So this is the meaning of you are asked to list out the factors of the two numbers. Next, there should be a typo there, which is called not list out the factors, but you are listing some, or not the, some multiples of 12 and 30 respectively. So the meaning of multiples, that means you are having 12 times 1, 12 times 2, 12 times 3, times 4, etc. Maybe I'll write some more, like 60, 72, 84, 96. Because I'm going to demonstrate some ideas with you, so that's why I write some more numbers. Well, for the multiples of 30, so it's easier to write, which you have 30, 60, 90, 120, etc. If you're smart enough, you'll see why I stop at 120. Coming up next, you are going to find the HCF and LCM of 12 and 30 respectively. And then so when you need to revise or recall the ideas between of these two terms, you have to see HCF means you are talking about highest common factor. In common factor between 12 and 30, you have 1, 2, 3, 6, and that's all. Among them, which one is the highest? We call the HCF. So that means it is equal to 6. Well, for LCM, we are talking about the multiple, least common multiple. So that's why when you check the numbers, the least one should be 60, next one 120. If you continue to guess, you will see we should be talking about 180 for the next common multiple. Among them, the smallest one, the least one, will be your LCM, which is called 60 in the question. But now, when we come to secondary school or high school, then it will be quite terrible to list out all the factors, all the multiples of the two numbers you're going to study. So that's why we have another way, which is we need to list out the numbers as a product of prime factors. And then so here we revise a term called prime, that means prime number, including 2, 3, 5, 7, 11, etc. And then for 12, you will be breaking down it into 2 squared times 3. Do you remember how to do it? Yes, it's by division. 12, we try to divide it by the smallest prime number, which is 2. You have 6, you continue to divide it by 2, and you have 3, and that's all. Well, for 30, we also start from 2. But 2 is not divisible. 15 is not divisible by 2, so that's why we choose 3 and 5. And then so as a result, 30 will be 2 times 3 times 5 instead. But these are called, you write it down as a product of prime factors. Coming up next, how we can read the HCF and LCM between the numbers. We have to pay attention to it. So let's start from HCF first. It's easier. HCF will be some numbers which are common between them. So that's why you have 2 and 3, and that's why 2 times 3, which is a 6. Repeat again, HCF will be you are searching some common factors among the two products, and they are 1, 3, and 1, 2. But while for LCM, it will be more troublesome because we are talking about multiple. And 2 and 2 squared, we will take the larger power, which is 2 squared. 3 and 3, we just pick 1, 3. 5 only owned by 30 is fine. We also choose it, take it as the LCM. And after checking for calculator, you also get 60 as a result. So please note that the way to read the HCF and LCM between two numbers in this quick example. Next, I'm going to give you some more examples as demonstration. For example, like number 1, how about if I have the number like 2 squared times 3 times 5, and then also 2 times 3 times 5 squared. And now I list out HCF first. How about we do it first? HCF 2 squared and 2, so we need a 2. 3 and 3, so we take a 3. 5 and 5, we take a 5, so that's why it's 30. Well, for LCM, you have, maybe I change to yellow, 2 squared and 2, so we take the 1 with greater power. 3 and 3, the same, so we take 1, 3. 5 and 5 squared, we take 5 squared. And you check the calculator, the outcome is 300. Is that alright to you? How about we try one which is more complicated? For example, like 3 squared 5 times 7. And you have 2 times 3 times 5 times 11. For HCF, then you check for 3 squared and 3, you take a 3. 5 and 5, you take a 5, so that's why it's 15. Well, for LCM, it's nothing fun because there are a lot of numbers as well as the numbers is quite big. 3 squared and 3, 3 squared. I forgot to read the 2 in the second number, which should be included in the LCM. 5 and 5, you have a 5, 7, 7, 11, 11. So that's why after you multiply the numbers by your calculator, so what should it be? Wait, let me check. It's 2 times 9 times 5 times 7 times 11, which is 6930. And this is the general picture how you write or how you find out the LCM HCF between numbers. Coming up next, of course, we extend to polynomial, as we did a lot in this chapter. So the first thing we have to do is we can't have expanded form because you can't see the factors in the polynomials. Instead, you need to do factorization. That's one of the reasons why you need to know factorization cross method in this year as well as last year. And because we need to factorize it in terms of some factors, and then in order to read the common HCF and LCM. So each of them can be factorized by cross method, and you try to do it by yourselves. And I'll just write down the answers very quickly here for you. In order to get the HCF, so as we mentioned before, you are searching for some common terms, common factors between them. And I only have x minus 2, so this is the HCF. Well, for LCM, so x minus 2, of course, is one of our member, but we also have x minus 1 and x minus 3 in the expression to be considered, to be included. And that's why LCM will be the product of these three brackets. Can you correlate it with the situation or the method we did use in numbers? If you can, it will be easier for you to understand how to find LCM and HCF between polynomials. If it is alright, then how about we take a look in the coming very quick example from my exam paper. If you are going to find the LCM, so let's check. 210 and 30, LCM is 210. Hopefully you can do it by yourselves. X and x squared, so we take x squared. Y squared and y, we take y squared. And finally, we still have a z in the second expression, you have z. So that's why that is how you get the answer C. The last example will be in example 31. Again, finding HCF and LCM. So let's read HCF first. A and A, so we have A. B squared and B, we take B. C and C cubed, we take C, and that's all. So that's why it should be answer B or answer C. Followed by LCM, we take A and A, we have A. B squared and B, you have B squared. C and C cubed, you have C cubed. And that's why the answer would be a B in this example. If you grasp the idea about finding LCM and HCF in numbers, Hopefully this section is not very hard to you.